Good evening, everyone. My name is Jan. I am CTO and co-founder of Orbit. So Orbit is an early-stage B2B fintech startup based in Houston, Texas. What we do is we help small and medium-sized businesses to access capital for their business growth. And at the same time, we provide an AI-powered CFO to help them manage their cash flow better. So before I get started, I want to do a quick survey. So how many of you here are technical? So engineers, technical, okay. There's a lot of technical folks. I have to impress you guys.
We're all fired, right?
No. Okay. So this presentation is designed for both technical and non-technical audiences. So for our engineers, my goal here is to show my takeaways when I was building with AI. So how can we actually become a 10x engineer instead of like 0.5x engineer? We have to debug with AI. For non-technical audiences, my goal here is to walk you through a structured framework so you can go beyond one-shot vibe coding and actually go from idea to production. This presentation will be structured into 3 parts. First part, I will go through some paradigm shifts. And second, I will go through an actual project building with AI agent. And third, I will provide some tips and tools that you guys may find helpful. For the paradigm shift, first, there is a concept that I call the collapsing talent stack. Before AI, each of the team, like product, engineering, and design, have very clear boundaries. So product manager design the PRDs, engineering write the code, and designer design the UI UX. But with generative AI, what I've seen with the startup ecosystem, especially with small teams, is that we now find a minimal viable engineer who is a single person that can do all these 3, like engineering, product, and design. Even for some non-technical folks, they started to learn all these 3 skill sets, and they become this minimal viable engineer. And the second paradigm shift is from T-shaped to pillar-shaped. I believe many of you have heard of this idea of becoming a T-shaped talent. So you have a broad enough skill set and deep expertise in a specific domain. But now, what we are seeing is a professional needs to develop more pillars of expertise. One pillar is not enough anymore. So you probably need to have many different skill sets so you can combine and make yourself more resilient and more versatile. And the third shift is from deterministic to probabilistic. For traditional software, when user types value A, they will guarantee to get value B. So it's very predictable. But with large language models, as many of you experience with ChatGPT, you ask the model the same questions multiple times, they will give you very different answers, but they are equally valid. We are transitioning from deterministic model to a more probability-oriented thinking. All these 3 paradigm shifts has dramatically changed the way we build and ship in the age of AI. And in part 2, I'm going to go through an actual example. So here's the typical software development cycle. We first start with discover. We will go through the code base and see what is existing in the code base and search for documentation, things like that. And then we design what is the scope of the project, what is the tech specs, what is the architecture. And then we move to the build stage. So we will actually implement the code, write the test, create the commit, and push it to GitHub. And then the 4th stage is deploy. We would automate the CI/CD, configure the environments, and manage deployments. And finally, we have support and scale. We may need to debug the errors, do some refactoring to make our code base better, and then monitor usage over time. There's a saying that shipping is your company's heartbeat. The faster you complete a full cycle, the faster you grow, as demonstrated in the iteration loop on the right. So here's a very simple project. We are building a Houston housing dashboard. Since this project is for both technical and non-technical people, I designed a very simple front-end app so that all the audience can understand what is happening over here. And you can scan the QR code to preview. So imagine you are a real estate investor who want to keep track of all the economic indicators of the housing market in Houston. And you want to develop your own dashboard to track all the important data points and statistics. Here, we want to gather data from Federal Reserve Economic Data API to get relevant data for the housing price and inventory. And in this example, we're going to use Cursor for IDE, Cloud Code for AI coding agent, and we're going to set up 2 MCP servers, 3 in Playwright, using v0.app for iteration, and building on Next.js for front end, and deploy on Vercel. So for a full-fledged app, we would typically need a dedicated backend, authentication, database, all the backend heavy logic. But we're not demonstrating in this particular project. So before we dive in, I can go through how does an AI coding agent actually work. For the non-technical audience, I can explain this through an analogy. So imagine your AI agent is a customized chef. And what the chef has is a memory of all the recipes and all the knowledge of how to make a delicious dish. And they have a bunch of tools as illustrated on the right. So it can read the terminal, execute commands, do a bunch of stuff. And then for the AI coding agent, what you do is you interact with the agent running on your computer. The AI agent will send related prompts and related queries to the large language models, depends on whatever model you're using. And then you get a magic answer or a magic modification of your code files. So let's go through this iteration process step by step. First is discovery. Because in our current project, we don't have any existing code exist. So in this example, I'm just going to ask Cloud Code to research the Federal Reserve API, see what I can do with this API. Because I really hate reading documentation. I'm not a reading person. I just want to have the answer given to me, magically. So here you can see that the AI agent is doing the web search and is pulling all the information. And fast forward, we can see.
The initial query that you gave it.
Oh, sorry. So the query is, help me to research the Federal Reserve API and what I can do with this API.
Okay.
So the agent go ahead and do the research for me. Here you can see a list of updated to-dos of each step that it completes, and it gives a list of API capabilities and the data sets that are relevant to Houston housing market. But many of you may know that AI can hallucinate sometimes. It will just come up with random answers that doesn't really exist. So in this case, we have to fact check our AI agent. So here it gives a dataset ID, and I have to look up online and make sure to actually match what the API can provide. Okay, then we move on to the design phase. During the design phase, I typically ask the AI agent to write a PRD, product requirements document. So I would give all the context, say, okay, the prompt here is, given all the research you've done for the API, write a PRD for me, what this dashboard should look like, what are the features that should be included here. The reason that I write the PRD, or our team at Orbis spent a lot of time polishing the PRD, is to make sure that AI has a single source of truth to reference. It knows exactly what to build, instead of just make up some random features that are not really in the requirement. Once I'm satisfied with the PRD, it's time to build the first iteration. Here I'm using v0.app, and you can use any of those resources like Lovable, Replit. There's so many tools out there that can help you to spin up a very lightweight MVP. So in this case, I just upload the markdown file for the PRD, and the AI agent is thinking and generating all the front-end UI components. So fast forward here. Okay, now we have a dashboard that we can just get started. Before generative AI, you usually have to ask a designer to design all the things on Figma and then hand it off to a developer to translate that thing to the code. But now it's very easy, especially for individuals or small teams, just to iterate very fast. I can use one click to auto-export from V0 to GitHub to get all the code generated by AI. And the next step, I want my AI agent to pull the GitHub repository so we can start to develop in my local computer. I don't want to write all the GitHub commands, so I just ask AI to do so. So it just like saves me a lot of time. I'm like, okay, it's done after like 30 seconds. Awesome, so we have a working prototype running on localhost 3000, but it's still using dummy data. Let's move on to the third stage, the build stage. Here's where we implement all the code and logic. So here I'm gonna share some useful tips when I'm working or coding with AI agent. The first tip is to define the sub-agent. Say you are the manager and you want to achieve a certain task. And you want to think about what are all the kinds of skill sets and people that you want to bring in your team. And in this case, I'm defining a sub-agent who's an expert in building front-end development in Next.js framework. I just use /command agent for Cloud Code, and Cloud Code just write all the job description for this AI agent for me. It's very comprehensive. It's like, okay, great, all the skill sets that I may not really have. And the next step is to set up MCP servers. So what MCP servers does is to provide additional set of tools for your AI agent so that they can use something that is useful beyond what original Cloud Code agent can do. Serena here, as an example, is basically giving an agent a set of tools to navigate your code base more efficiently. So you can reduce your token usage, make it more efficient and more cost-effective. Playwright MCP server is essentially giving your AI agent a set of tools to navigate the browser. So they can click on your browser and see what's going on automatically. And the third tip is to manage the memory for Cloud Code. What essentially this cloud.markdown file does is to design a notebook for the AI agent so that they can store relevant knowledge and context, and they can keep a long-term memory and remember what to do when the next time you interact with the agent, instead of they just like, the entire memory get wiped out whenever you restart the agent. Okay, here it automatically creates a memory file with all the important details of how to start and utilize these tools.
You just getting started. Oh, wait, there's more.
Yes, test-driven development. Okay, so here's it's interesting concept. I personally don't like to do test-driven development. It just feels like a lot of work beforehand, but it's much easier to ask agent to do so. So what we do is we first write the test, ask the agent to write the test, and then implement the code. So it's kind of like you're a teacher who wants to give an exam, and you write the answer sheet first, and then you write the questions on the exams, so that you can make sure that the agent follow the test, because it will fail the test first, and then they implement the code to make the test pass. So it has become much easier to implement this test-driven development for me.
Which test framework did you use to test your Next.js?
Jest, normal
Jest,
Jest, yeah.
You picked that or Cloud Code just picked it?
Kind of both. Like Cloud Code's like, do we want to use Jest? I'm like, yeah. Awesome.
Full vibe coding.
You set up a separate agent for testing?
Yeah, so I have separate sub-agents, one for just testing and debugger and different developers. So our Orbit team has 20-something sub-agents, and we will use the relevant sub-agent for each task. And I will also make sure that I add all the jobs descriptions so that the AI agent has some synthetic profile, meaning that they have been working in financial technology industry for 10 years. So that all the agents are like superstar in fintech that you're probably not gonna find on job market at all. So you can do your own assemble of AI agent, your own crew.
So because the number of tokens you're using can exceed so much, and do you limit the agents to use some specific number of tokens, or do you give budget? How do you do that?
So that's why I'm using the Serena MCP servers so that it doesn't just print out the entire code and use a highlighter, try to find the specific details, but try to find a specific class or interface so that you can save on token usage. Like,
So you're not specifically limiting number of tokens, saying that
uh,
giving budget?
no, but I'm trying to develop because Cloud Code had just released a /usage command, so I can integrate with that. If I realize one agent has been consuming too much of the token, I would just like kill it and then do something else. So that is a very great point. Okay, so now the AI agent has finished the test-driven development, write all the code, and then I asked it to use the Playwright MCP server to interact with the browser, look at what it does, and then basically doing kind of like a simplified end-to-end testing for front end.
And it's also showing how many tokens it's using it.
Yeah,
It's
so
hard to see for the people, but
yeah,
it's
it's
hardly using any tokens at all. 400 or
yeah, so here it shows on live how many tokens each query cost. So you kind of get a sense of, is this task too complicated, or you have to break it down into smaller tasks for agents to better manage the requirement. Okay, so here what the agent does is it literally just take a screenshot and scroll the entire page on itself. And I'm like, okay, then this page works pretty well. You're pretty much done. Okay, the next step is to check all the tests have passed and commit to the GitHub. Usually I spend a lot of time to make sure that the test written actually makes sense, because sometimes AI agent just write the test for passing for its own sake without really writing any logic. So I have to spend some time on code review and make sure that all the code is written in a logical manner and is related to whatever the business requirement. Okay, the fourth step is deployment. Well, for our very simple Next.js app, is very straightforward to deploy. You can just push it to Vercel. But for a complicated backend service, we usually need to write the Terraform to automate infrastructure as code to deploy on AWS or GCP Azure. In Orbit, we have a couple AI sub-agents who are expert in Terraform, just to write Terraform and make sure that all the Terraform written are secure, and we utilize the cloud resources very efficiently. And here we can check that the actual data matches the data sets provided by the Federal Reserve API, the actual website. Okay, then let's move on to the final stage, support and scale. So in our project, we don't really have that much to support and scale, but I just want to mention the refactoring use case. Again, we can leverage the Serena MCP server to save some tokens. Here is a list of tools that the agent can use to make sure that they only call the relevant tool sets and can save you some money if you're running your agent live. Okay, finally, part 3, some tips and useful tools. The first tip is to use Git worktree to run parallel agents. So you may want to run multiple agents at the same time, and you don't want them to step on each other's toes. So you can just spin up separate work trees for different features, each feature for a specific agent. And the second tip is to use AI agents for automated PR code review. So in our case, we have 3 parallel agents running at the same time when we push code to GitHub. So CodeRabbit would generate a very nice diagram of the key features of what the code has been changed, so you can understand visually. And the GitHub Copilot will give some recommendations about specific lines to optimize. And Cloud Code, again, I'm using Cloud Code to review the code that it generated for itself. And it will usually recommend or analyze some checkpoints, like is there any security issues or any domain logic issues that happen in the code.
I have a question. For non-technical people, when I've done, and I ask it to check for errors, one of the things I've noticed is, because like you mentioned, it's not necessarily it's not deterministic, it's probabilistic, I guess.
Yeah.
I can't really say that, but it seems like fix it, but then it messes something else up, and it fixes something else. I mean,
Yeah, I understand.
how do you check it and make sure that it doesn't kind of corrupt the nature of
Yeah,
Yeah.
yeah, I totally get it. Because it's non-deterministic behavior, what I usually do is don't rely on one single agent. You can leverage sub-agents to make sure that one single agent just do one specific task very, very well. Say if you check error, you just check error. And you're gonna have another agent just to fix the error. And another agent just to like make sure that the fixed errors doesn't produce more errors. You get my idea. So it's kind of like a very specific role for each task.
And then you mentioned earlier that you manage your long-term memory with Cloud.md. Do you create that using the init, like /init,
Yeah.
whenever you start the
Yes.
project? And then how do you keep updating the memory in case it needs to be?
Okay, so I can share like very useful tips for Orbit team. So what we do is we have a specific app just for documentation built on Next.js as well. So it's called Nextra framework. So we write every single domain aspects in that documentation. So basically it's like a dictionary or library for your entire business related logic or technical related logic. So when the AI has going out of the memory of say cloudcode.md, I will refer it to our internal documentation. So it will keep referring to the single source of truth for the entire business or entire team. I hope that makes sense.
Can you go back to slide 26?
Let's just finish this presentation so we can have more Q&A. Okay, so here's a funny part. I'm not sure I can play it very well, but
Cloud Code needs your attention.
so you kind of hear it. So whenever Cloud Codes finish the task, it will just say it out loud. Cloud Codes needs your attention, because an AI agent can run say 30 seconds all the way to like an hour or something. There's a funny story that I was in a Zoom meeting and I forgot my AI agent was still running, and everybody heard Cloud Code needs your attention. It was like okay, everybody knows I'm using Cloud Code. And another tip is deepwiki.com. Here is a very useful website to learn about the architecture from open source projects. I find the documentation on this website has much better visuals and explanation than what I find on official documentation. So you can use it for reference. And then here are some templates that you might find helpful, like the list of sub-agents for Cloud Code, cursor rules, and some MCP servers from, say, database connection all the way to how do I integrate with Stripe API, things like that. Okay, so a quick recap. In the first part, we go through some paradigm shift. And the second part, we go through an actual project. And the third part, we provide some useful tips and tools. Overall, if there's only one takeaway I want you guys to leave tonight is to define your own iteration loop. So many of the folks here may not be technical or engineers. You may be marketing or business development, but you can define your own iteration loop and use AI to speed up the process for every single task. So you can iterate faster and grow faster. Okay, that concludes my presentation. Here's my LinkedIn, here's the website.
Got time for 3 questions.
You can ask questions on LinkedIn.
Yeah, please do that. Yeah.
Who were the actual, I understand they're in real estate, but what part of real estate are they in, or is there many different people that are using this app, and is it deployed and sold?
No, this is just for the sake of this presentation.
Oh,
But-
okay. Never mind.
But my point is you can develop your own customized app without even need to know how to code. Just the entire process, you can follow it. Yeah.
What level of Cloud Code are you paying for to run this?
I'm paying for the maximum,
The maximum?
the $200 one.
20 wouldn't be enough?
No, I would rather pay for $200 per month than pay extra developer.
Is the limit even at max?
Not really. I rarely hit the $200 max because the Cloud Code is time-based. It will reset the limit every 4 hours. Versus if you're using Cursor AI, there's a maximum token. It's not time-based reset. So I would prefer the time-based reset.
All right. Let's run the clock.